in example 4, we have these 3 cones that are all similar, and I want to find the volume of each cone. Well, let's start with cone 1. To find the volume, we're just going to find the volume how we normally do. So it's 1/3 times pi r squared h. Notice my radius is 5, but I've got to calculate the height. So if I draw in my right triangle here, and I'll put in 12 here, and I know my radius is 5. So I can use Pythagorean theorem, and I'm going to say 12 squared equals 5 squared plus, well, let's call it h squared, h for height. So 144 equals 25 plus h squared. And if I go ahead and I do that, 144 minus 25 will give me the square root of 119. So my volume is going to be 1/3 times pi times r squared, which in this case will be 25, times the square root of 119. Well, we got a lot of things going on. That's too much. Let's just round this. So if I take 25 times the square root of 119, and I multiply that by pi, and I divide that by 3, I'll get 285.5894. And yes, I'll round that later on, but for right now, let's just write it up with 4 decimal places. And that is the volume of my first cone. Now to find the volume of the second cone, I'm just going to use my fundamental theorem of similarity. And so we're going to say my ratio, K, that's going to be 5 to 6. But I'm doing the volume, so my volume is going to be 5 cubed to 6 cubed, or 125 to 6 cubed is 216. So now I can solve for the volume of cone 2, because I know the volume of cone 1 is 285.5894. And what I'm going to do is I'm going to solve for cone 2, call that C. So now we can cross multiply there. If I take 216 times 285.5894, and then we divide that by 125, we will get the volume of cone 2, which we'll say is 493.5, and that will be cubic inches. Cone 3, notice that's congruent, not just similar to cone 1, because they both have a radius of 5 inches and they have the same height. So that's going to be 285.6 cubic inches. And there we have cone 2 and cone 3. Now in our last problem, let's take a look here. We have these 2 rectangular pyramids with square bases. So I've got a square base here. That's my first one. And then it says they have surface area of 98 and 18. Now, area is k squared, isn't it? So in other words, k squared is 98 to 18, which we can simplify to 49 to 9. And I know the base of the edge of the larger rectangular prism is 9. What's the perimeter of the smaller one? So in other words, first off, that works out kind of nice. K, I'm only looking at perimeter, so I want K. So K then is 7 to 3. And I'm told that the larger one measures 9. And then I want to find the side length of the, now remember, I'm only finding side length here. I'm not finding the perimeter, but it's going to be a square, so we should be able to do that. So now we're going to say 7x equals 27, divide by 7. So in other words, I've got this square, and it's 27 over 7 for each side. So to find my perimeter, I'm going to say 27 over 7 times 4. And if I take 27 over 7 times 4, well, 7 doesn't go in there, so I'll take 27 times 4, and I'll divide that by 7. And we'll just write it out, and we'll say 15.4. And this would be centimeters, wouldn't it? And there's your answer, because we're just finding the perimeter of, what is the perimeter of the base of the smaller prism? So my smaller prism has a perimeter of 15.4, because that's all they were asking. They're finding side length here, given the areas. So the key is, hey, do I need to use K? Do I need to use K squared? Or do I need to use K cubed when we're looking at our problems? And then set it the proportion like we normally do, and then you have it.